How many ordered pairs of integers mn satisfy the equation m squared plus mn plus n squared equals m squared times n squared? Okay, so first let's observe that it's a symmetric equation in terms of m and n. So first, let's suppose m is the bigger one between the two in absolute value. Then, so it looks like the right-hand side for bigger values of m or n, m and n, the right-hand side should be very big compared to the left-hand side. So we are going to use inequalities, and we are going to bound the left-hand side. So m squared plus mn plus n squared is less than m squared plus, and both m and n are less than m absolute value of m. So we have that. And then n is less than absolute value of m. And absolute value of m is m squared is the same as m squared. So we end up with 3 m squared here. And this is supposed to be m squared times n squared. So if either m is 0, in which case n is 0, or we have n squared after canceling m squared or dividing both sides by m squared terms, we get n squared is at most 3. So if m is 0, we have n is also 0, or we have this. And in this case, n is -1, 0, or 1. These are the only possibilities. Okay, so we are gonna do case work based on this. If n is 0, let's start with that. If n is 0, we have m squared equals 0, so m is 0. If n is plus minus 1, then n squared is going to be 1, right? So m squared plus, and n is plus minus 1, so let's say plus minus mn plus 1 equals m squared. So we get, well, this is m, n is plus minus 1. So we get m is minus plus, just the opposite of n. So the solutions we get are 0, 0, 1, -1, and -1, 1. And observe that we assumed m is the bigger one, but we ended up with both absolute values being the same. So if n were the bigger one in absolute value, we would still get these same pairs. So in total, we conclude that there are 3 solutions to this equation.